So properties of logarithms. There are three properties that we'll need to know. And I'm just going to go ahead and get them all out of the way and present all three of them to you, and then I'll show specific examples of how to work them. So the first one is, let's just call it number one, the product property. And I'm not going to write property, just product. So what it says is if you have log base b of x times y, the product, multiplying. That's what you're doing here, the product of two things. So you're multiplying two things in here. Then you have this one log that's multiplying x and y. You can break them apart into two different logs now of x and y. So what I mean is this, log base b of x plus log base b of the second thing you're multiplying together times itself, y. And this extends beyond just two. You can multiply, if you're multiplying three things in here, so say there was a z, x, y, z, then you'd have another plus log base b of z. Next we have is the quotient. Quotient property. So it says if you have log base b of x divided by y, you might be able to guess what this one's going to do. It's log base b of the top, x, minus log base b of the bottom, y. Log base b of x minus log base b of y. So the only difference between these two is up here, it's the product, multiplying. We're breaking them apart and we're adding them together. Here, it's the quotient, we're dividing, we break them apart and we subtract. And then the third one, which is quite useful and will be used a lot, is called the power property. It's simple, easy, and it allows us to do a lot of stuff. So log base b, we have log base b of x, and that x is raised to the p power. What we can do is we can take this p and we can move it to the front of the whole thing, and now we're multiplying p times log base b of x. Alright, those are our three properties. Now let's look at some examples. Example 1. And let's just say we're going to say expand. So we're going to start with something like this or one of these, and then I just want you to expand it as much as we possibly can. Part A, let's say we had log base 2 of 8x. So first you need to be able to identify what we're doing. We're multiplying these two things together, 8 and x. So that means we're going to use the product rule. It says if we're multiplying two things together, then we can break them apart in two different logs and add them together. So this is equal to log base 2 of the first one, 8, plus log base 2 of x. Alright, and so that's not actually our final answer. We can do some simplifying because this log base 2 of 8 can be simplified. So this is where the previous lectures come into play. They're going to be, that's what the previous lectures of converting from logarithmic to exponential are so important, because they're going to be embedded in smaller portions of these bigger problems. So just do some side work and eventually you'll be able to do some of these in your head. We have log base 2 of 8, and let's set it equal to y, some variable we're not using in the problem. And then we're in logarithmic, so convert it to exponential. Base 2, exponents y, and that's equal to 8. So we know that y has to equal 3 now. So that's what goes here. This is equal to 3 plus log base 2 of x. Alright, you're going to have to start being able to combine all of these sections. 4.2 all the way up to this one, and the next one will be combining even more. Let's look at part B. Natural log of 5xy. So here we're multiplying three things together, and so we're using the product rule. When we're multiplying three things, it works the same way as two. We just break each of them out separately and add them together. So the natural log of 5 plus the natural log of x plus the natural log of y. Hopefully those are pretty easy for you. Part C, what about the natural log of c over d? Well, here we're multiplying two things together. And I guess I should have said this earlier when I did this problem. ln, remember, is log base e. So all these same rules still apply to natural log. Sorry, I should have said that earlier. So the same rules still apply here. I'm dividing these two things. So now I can break them into two and subtract them. So the natural log of the top minus the natural log of the bottom, d. All right. Part D. What about this one? Log of x over 100. You pause and give this one a try. All right, so I'm I'm dividing two things here. And so I can break this up and subtract them. So I get log of the top minus log 100. All right, and you got to be careful because that's not your final answer. You have to remember that we can reduce this log of 100. So we'll do a little side work. Log of 100. And let's set it equal to something, let's call it m. And so what is my base here? If nothing's written, that means my base is 10. And then my exponent is m, and that's equal to what's left over. So that tells me m has to equal 2. So that's what is replaced here. This is equal to log x minus 2. All right. And what about part E? Let's say we have log of x divided by, let's call it y times z. Oh, my bad. Log of x divided by y times z. So, typically when you're expanding these problems out, you typically want to start with doing the quotient rule before you do the product. So here, go ahead and break these out into two logs using the quotient. So it's the top minus the bottom. Log of x minus log of y times z. All right, and then this is equal to log of x minus log of y. Because we're multiplying two things here, we can add them together, break them apart and add them. Log of z. All right, so if you wrote this answer and you agree with me, we would get this problem wrong. The reason is because this negative right here, it's minus this whole thing. So if we manipulate this at all, it still has to be minus this whole thing. So we have to have parentheses around that. So it's log x minus all of this in parentheses. So there's one more step here. I'm running out of room fast. Log x minus, so distribute this negative into both of these terms here, minus log y minus log z. And that would be your answer here. All right, that was part E. Let's look at F. Let's say we had log x squared. How can I change, rewrite this, or expand it? So the only thing we can do here would be to use the power rule, which the power rule says you can take this exponent and you can bring it to the front, and now you're multiplying. So you get 2 times the log of x, which comes in handy. You can also have we could have something like this. Let's say log of x plus y divided by z, and all of that's raised to the 1/2 power. All right, so we can't do anything here until we deal with this exponent. We can't use a quotient or anything here. All right, so typically when you work these, it will be power rule and then quotient, and then if there's any multiplication, you can break them apart. That's typically. Now, it's not 100% on every problem. You gotta evaluate on a case-by-case basis. But here, we're going to do the power rule first. We have to bring this 1/2 to the front, and now we're multiplying. So this is equal to 1/2 log of x plus y over z. And now we can deal with the division here. So if we're dividing, we can break these into two different logs. So this is equal to 1/2 log of x plus y, the top, minus log of the bottom. All right, it's easy to forget this x plus y is one thing, so make sure it stays in parentheses there. All right, and we made another error similar to the one a couple examples ago. So this says 1/2 times this whole thing, 1/2 times this log. So if we do anything to this log of x plus y over z, then this whole thing still has to be multiplied by 1/2. So we have to have parentheses here, or brackets. I'm putting brackets here just because too many parentheses can get confusing. But don't get confused by the brackets. I could put parentheses. All right, and then the last thing to do, if we're expanding this as much as we can, is we have to distribute this 1/2 into each of these terms. So that's equal to 1/2 log x plus y minus half log z. And that would be where we stop for that particular problem. All right, so that's a good example. E, F, G, H. No, let's start over. Let's start with a new example. Example 2. And this would be type of problems you'll see on the exam. So give it a little star or something here. And I'm just going to shorthand it and say expand again. So log base 2 of z cubed over x times y to the 5th. All right, you pause the video and try it yourself. So first thing I notice is I'm dividing these two things. So let's go ahead and break them apart. Log base 2 of z cubed minus the bottom. Now what can we do? Well, you see we can do the power rule here, but we couldn't do it here because this x is throwing us off. So usually you do the power rule first and then you'll do it last. So you'll do the power rule first, and then you'll do the quotient rule, and then the product rule if there's one, and then maybe the quotient, then the power rule again at the end. It's just depending where there's exponents and the time that you need them. So this is not the time to do the power rule first. We have to completely expand this out first. So we have to take care of this x times y to the 5th. Log base 2 of z cubed minus log base 2 of the first one, x, plus log base 2 of y to the 5th, the second one. And I made the mistake again, because it's minus this whole thing. So down here it still has to be minus this whole thing. All right. The next step is I'm going to distribute that negative into both of these terms. So this negative goes here, and it goes here. You multiply to both of them. All right, now we're almost there. The last thing to do is the power rule and to get those exponents out of there. So now we have 3 log base 2 of z minus log 2x minus 5 log 2y. So these exponents move to the front of each term, and it stays there at the front of the term. So that's as far as we can expand this one. All right, look for something like that on your test potentially. It'll be a little different than that, but just be prepared. So we're expanding, and that's all we've been doing. But you can go backwards, actually. So I'm going to come back to the previous page we were looking at. So what we're looking at is we're starting at one of these positions, and we're going here. But what we can do is if we're in this position, one of these, we can go backwards to one of these, to how these look. And that will be called condensing. At least that's what I'm going to call it for now. Example 3, condense as much as you can. All right, so let's call this one part A. And this is just reverse of everything we've done, so you have to know these backwards and forwards. Let's look at 3 log A minus no, I don't want to do that problem. Sorry. 3 log base 2 z minus log base 2 of x minus 5 times log base 2 of y. All right, so we're condensing now. We're going in the reverse direction. So typically, one of the first things you'll do is the power rule. And it's not always going to be the case, but typically that's what will happen. So you can see here that we have this 3 out front and this 5. So we can bring that back up here into the exponent. So this is equal to log base 2 of z cubed minus log base 2 of x minus 5 log base 2 of y to the 5th. All right. So now what we're dealing with are 2 minus signs. So that means we're going to have to use what property? The quotient rule, the quotient property. We're going to have to use it twice here. But what happens if you do the quotient property twice is you wind up with a fraction over a fraction, which can get a little ugly. So the easy thing to remember here, well, I don't want to say easy thing to remember, but the easier thing to do, in my opinion, is to do what we did on the previous problem. So, but in reverse. Let's look at what we did on the previous problem. So on the previous problem, this is what we're currently doing, and this was the previous one down here. On the previous example, we're at this same step right here. This is the same exact problem. So notice this one in the rectangle and where I started are the exact same problems. So all I'm doing is I'm working backwards. All right, that's what we're doing up here. We're going to work backwards. So we've already up to this step. We've completed this step. So now we're here. We have log base 2 of z cubed minus log base 2 of x minus log base 2 of y to the 5th. So those are the same. So what I want to do now is I want to go back another step and see what I did. So I was here with these 2 negatives, and so I distributed that negative in there. So what I can do to get backwards is I can factor the negative out of these 2 terms. So that's what I did. I'm going to factor both negatives out and then put these in parentheses or brackets. And that makes life a lot easier because now in here I can do the product rule and then I can do the quotient rule. So let's look at that. So the key here, and know this for the test. Know for test. All right. We have these 2 negatives, and we're going to factor that negative out of both of them and put them in parentheses, brackets in this case. So minus, and now when I take a minus out of log base 2x, I'm left with log base 2x. Then I take a minus out of this minus log base 2y to the 5th, and I get plus. Now I can just deal with what's inside of these brackets. So when I'm combining, it's now x times y to the fifth. And parentheses help there. So lastly, I'm subtracting these two, and they have the same base. So that means I can write them as 1 log and now divide them. All right, make sure they have the same base. That's a mistake usually made sometimes as well.